I wanted to create this video because what I've seen sometimes, like especially on projects at the beginning or new projects where you're deciding on a language, is a good example would be Rust and Go, where someone might say, "Okay, we're going to go with Go because it's easier to learn, and Rust is complicated or Rust has a steep learning curve." And what I want to argue here actually is it's not so much that Rust has a steep learning curve, it's like software engineering has a steep learning curve. And if we take Rust, if you break it down into what you actually need to learn, so for example, one of the concepts that you're going to see a lot is the concept of option and result. Now, these are not specific to Rust. They've actually come from Haskell and possibly other languages, and actually they're being incorporated into other languages as well. So I think Java has option now and also C sharp. So as a software engineer, if you know these concepts, for example, option result, algebraic data types, which is basically like using enum, so you can kind of create these the way that you can model your data into these structures and make it very tight with the compiler, and traits and resource acquisition is these concepts, a lot of them have come from other languages and we kind of should know them, so that when we are making this decision about which language to use, we understand, like when we use Go, what we're giving up. Now, my argument here would be these concepts are there to protect us somehow. So for example, options are a great example. If we just run down here, I've got a coding example. So if we take Go, and we've got this get user function, and that's going to return nil. So what we have to do in Go is always check the result to see if it's nil or not. And if you look at Go code bases, you'll see this an awful lot. Now, in Rust, we have the same function, but it can return an option, okay? And we have to do the same thing, but instead of returning nil, we return none. And you think, "Oh, what's the difference?" Well, the difference is in Rust, you have to check that value, so you can't ignore it. The compiler is going to complain at you straight away. So my argument there would be we're going to get less issues in production because the compiler's catching those issues like earlier on. So my argument then is, okay, we've got these different software engineering principles that Rust implements and Go, for example, doesn't. And what that means is if you ignore those issues, they kind of don't go away. They just kind of end up in production as something that you're going to need to fix later on. So you just have this probability thing. You say, okay, we can use Rust, which has got a better probability that we won't have issues in production, but we're going to have to be software engineers and learn some of these concepts. Or we go with Go and we don't learn those concepts and we accept that later on, we're going to get more issues in production. And that's what I'm saying here. It's a learning curve or bugs in production. Then what I'm saying is, okay, Rust is a very general purpose language. So it's kind of like a one language does everything. We can learn Rust, we go through that learning curve and we have all of these concepts. But now we've also got the ability, for example, to create embedded software because we can use Rust for that. We can create software that runs only in the browser because Rust will compile to WebAssembly. So it's kind of like we get all these software engineering principles, great, and this flexibility to use the same language in lots of different places. And I like the idea of that because, okay, we can learn lots of languages, but you never really get great at lots of languages. It's better if you can get great, I think, just at one. Yeah, and then I've said, okay, yeah, but lifetimes. Now, lifetimes is specific to Rust. It's non-trivial. What I would say though is we don't use them that often day to day. So they tend to be something that you need when you're, for example, extending a library. And I've used them, for example, with the Axum framework, where you might want to create your own thing that can handle a request and you need lifetimes for that. But we live in the age of ChatGPT now, so I just get it to generate them. It can figure them out. And so it's not such a big deal. And then I would say, as we are entering an age where we're going to generate more and more software with AI, it's maybe also a good thing to use Rust because it's such a tight language in terms of the compiler that when we put that code out there and get it to compile just in VS Code, if it doesn't compile, we know we've got issues straight away. Would we know that with some of the other languages? I'm not sure. So that's it. Rust isn't too complicated. It's intentionally strict. It's not too complicated, especially if you already have that foundation of software engineering skills with these different software engineering best practices. If you know those, when you come to Rust, you're going to learn Rust very quickly. If you don't know those, Rust is going to teach them to you. It's a win-win. Okay, that's the end of this. Thanks for watching. I'm going to have more videos like this, so you want to hit that subscribe button so you can see them. Thank you very much.